Solve the following equation. X over x minus 2 plus 2/3 is equal to 2 over x minus 2. Now, since this is an equation involving rational expressions, the first thing we want to do is to get rid of the rational part, right? We want to get rid of all of these denominators to make the equation simpler. In a sense, to make it just a linear equation involving x that doesn't have any sort of rational expressions, because we know how to do that. So what we have to do is we have to multiply both sides of the equation by the LCD, which is going to get rid of both sides of the denominator. So first, finding the LCD of each of the denominators, which are 3 and x minus 2. The LCD of 3 and x minus 2 is just 3 times x minus 2. So now we want to multiply both sides of the equation by that LCD. So x over x minus 2 plus 2/3 is equal to 2 over x minus 2. And we want to multiply the left side by 3 times x minus 2. And we want to multiply the right side by 3 times x minus 2. Right? So doing that, I'm just going to distribute, and I'll worry about reducing later. So distributing straight, this becomes 3x times x minus 2 over x minus 2. Right, all I did was put the 3 times x minus 2 in the numerator and leaving everything else alone, right? So this becomes 2 times 3 x minus 2 over 3 equals 2 times 3 times x minus 2 over x minus 2. So now that we've distributed, we are in a position where we can cancel some stuff out, right? There's an x minus 2 in the numerator, and the denominator we can factor out and cancel from the first term. From the second, we've got a 3, and from the third, we've got another x minus 2. So now notice that I've actually canceled out all 3 of the denominators, which is what I wanted. So we did something right here. So what's left over? 3x plus 2 times x minus 2 is equal to 2 times 3, which is 6. And now distributing this 2 into that difference, we got 3x plus 2x minus 4 is equal to 6. So 5x minus 4 is equal to 6. And then since we want to solve for x, we want to add a 4 to each side. So 5x is equal to 10, which means that x is equal to 2. And so that is our solution. And now, in order to check to see whether our solution actually works, we should plug it into the original equation. So what was the original equation? It was, let's rewrite it down here. So to check, we want to plug x equals 2 into, into the original equation, which was x over x minus 2 plus 2/3 is equal to 2 over x minus 2. So plugging x is equal to 2 in, we got 2 over 2 minus 2 plus 2/3 is equal to 2 over 2 minus 2. And simplifying, we have 2 over 0 plus 2/3 is equal to 2 over 0. So now notice that we're dividing by 0 in both of these terms. So when you plug in x is equal to 2, it actually gives you terms which are called undefined. Right? That's what happens when we divide over 0. We get something that's considered undefined. So as it turns out, x equals 2, even though it's the only solution we found, it actually doesn't work. So in this case, it's actually called an extraneous solution. So the solution x equals 2 is an extraneous solution, which basically means that it solved the equation, but then when you plug it back in, it gives you something undefined. And so since the only solution we found was extraneous, then there is actually no solution to the system. So you can say the solution set is the empty set. Which is signified by this symbol over here, or you can just simply say, very bleakly, there is no solution. Either of these actually do satisfy the answer to the question.